Hello, this presentation is about basic machine operation, where I will show you how you can benefit from the usage of a 3-segment CAM profile. My name is Ilke van der Wol and I'm the Managing Director of the organization PLCopen, and I'm your host today in this presentation. The basic idea is to go from a mechanical solution with physical links to a control solution where software is the dominant factor. If we look to a mechanical CAM, we have a position-position relationship between the master and the slave. If we convert this to a control solution, then the master can become a virtual axis, and we link one or more slave axes to the master via a profile, in this case a CAM profile. And again, this is a position-position relationship through the CAM profile. So in a normal production, if there are no errors, you see that we have 3 segments. A start segment where we ramp in, a producing where we run the CAM in a repetitive mode, and somehow after so many cycles we stop the production there. So if you look from a timing perspective of the 3 segments, you see that we ramp in the slave to the master, that's on top. It's a 360-degree cycle every time. So we ramp in, we produce, and after so many cycles of production, we ramp out again. This is a one-on-one relationship, as you see. They're all going in the same pace. For this, we select a CAM table, and we use the function block CAM table select, where you see we have a master and a slave and a CAM table that we select upon. We have a periodic input if we do repeat or we have a single shot. We select if we want absolute or relative coordinates. And we select the execution mode immediately or queued. And what is important is the CAM table ID, which is the link to the CAM in, the next function block we use. Where again we see there's a master-slave relationship. So we link the slave to the master. And we do that with certain inputs where we can set the offset of the master, the offset of the slave table, a scaling from the master seen from the slave scaling, the factor there, master start distance where we sync to the master, and a master sync position where we sync in the profile. We have a start mode, absolute, relative, ramp in. We have the master value source, if that's a set value, or the actual value, where do we link to? And we got the link to the CAM table idea coming in from the previous function block. We used it 3 times in this case to create this profile. So you see the CAM in start, producing, and the CAM in stopping. We used 3 instances. We could use it with 1, but it makes it unclearer in the program. So again here you see this link between the master and the slave, which is in a one-to-one relationship. But the idea of a CAM profile is of course that we can change this one-to-one relationship to any profile that we want. That's what you basically see here. So we got a CAM in start where we do a profile. We do a CAM in producing where we do a repetitive movement. This way you see A and B are on the same level and the same curves in that sense. And in the end, we stop this profile again. And that's why I want to explain this 3-segment CAM profile to you. So here's an example. This is a cut-to-length machine where we have a workstation at the end where we do different operations. So we have the virtual master. We have a slave that unwind the tube from the roll that we then with the slave to servo cut to length, and when it's on the table we turn it around to divide it over the several workstations. And we have the tube clamps to be able to use it while cutting. And we have one of the tools at the workstation. In this case we can use one for sealing, one for filling and capping, and we can use any other tool there. This is the workstation on the rotating table. This is how it looks. Pull the tube out, we cut it, we clamp it, we cut it, we put it on the table, and we start working on the table while it is moving. So you got several sequences. We unwind till the right length, that's the tube. We clamp as preparation to cut. We unclamp, the tube falls on the table, turn table to first workstation. Run the workstation tool, sealing at the end, and then we redo it. We start another sequence of cutting the tube till the right length. If we look to the profiles that we use, we do for the servo 1, we unwind the tube. So you see a master versus a slave, and the slave goes to the required length of the tube. The cutting is servo 2, that's that part. And of course, part of that is dealing with the clamping. So we link that to a clamping functionality. And the third one is the round table. If the tube is on there, we turn it 1/6 of a full round, and the workstation works on that part. For instance, tube sealing. That's first step. This is supported with the two functionalities there. One is the clamp functionality on the bottom, and the other one is the tube sealing on the top, which is on the table itself. And for that one, we use what we call a digital cam switch, that you can link this again to the axis ref structure of your master axis. So overall, it will look like this. And now you can tune with all these profiles to make sure that you from a timing perspective, you can optimize this. So master-slave relationship, but you see that we sometimes have smaller profiles, so you clamp only on a smaller section, or your tube sealing can be done in that sense. So with your 3-segment cam profile and the cam table select, which we need 3 times for the different cam table selections, you can merge them into one function block and one environment. And you can create your own function block out of that one and add it to your library and reuse that over and over again. So it makes you more efficient in that sense. And efficiency is of course the tagline of PLCopen, the organization behind this all. We merge logic, motion and safety, giving you structuring, decomposition and reuse and less training. On top of that one, we add communications, exchange and training, of which this is of course one part. For this, we as organization need your help too. So keep in contact with us. Check our website, add your name to our electronic magazines. Mail me if you have specific questions. And of course, if you want to help to create these kinds of tutorials, contact me. Thanks for watching. More movies to follow. Bye for now.